graphical method. So we're going to do the graphical method of vector addition based on position on the graph. So here I have a few, let's see, 1, 2, 3, 4, 5, 6 different vectors laid out, and they have different x and y components. So these are the resultant vectors of x and y components. B has all x, and I didn't do any that are all vertical. So I have one that's completely horizontal, but no completely vertical ones. But that's all right. So what we do when we're doing graphical method is we look at the graph in the background, right? So these are kind of simple in one respect because all we have to do is count the number of units in the x direction for each of them, and then we create a data table and then add all of those whatever vectors are being added. So I've got some combination of vectors for adding. So we'll go with the simple a plus b vector. So we're going to add the a vector to the b vector. Okay, so if we were to move those things actually by position, that would be a completely different video that we'll have to do on another day. So everybody's aware those can be done, but we're not going to do those here today. Today we're just going to work on the graphical addition. So what we need to do is, let's see, let me get my marker going. We need to add vectors A. Let me get a color here that makes sense. And vector B. So we're going to do this particular combination first, A plus B, and we're going to add them by number of units. So A starts here. This is the tail of the vector. We can tell this is the head of the vector because there's an arrowhead on it. So we're going to add vectors, add heads to tails. Okay, so that means when we start on a tail end and complete the vector and then go on to the next vector. So we would be adding the b vector right to the end of this arrowhead. So we would add the tail of the b vector onto that right at that point. And then the b vector would extend out this direction, the exact same number of units that it's extending on the x direction now. So what we want to do is we want to create a kind of a unit analysis of the horizontal and vertical. So we're going to say A, and we're going to have an x value and a y value for A, and then we're going to have B, and the x and a y value. So we've got a little data table here, x and y, for A, vectors A and B. Okay, let me see if I can go back and erase those lines. Yeah, those are icky. So let's try that again. Insert some straight lines. So we have A and B. Oh, wait. Try again. Trying to insert some straight lines. Let's try again. Hang on. We'll get there. Nope. Insert. Straight line. Still not doing it, but that's all right. We'll just go on with crooked lines. I'm okay with that. So here's A and B. We need the x component and the y component for each. A, if we start here and work our way across, we're counting 1, 2, 3, 4. Looks like each of these squares is 4 units to the next primary line. And then 1, 2, 3, 4 units to the primary line in the y direction as well. So that's 4, 8, 12, 16, 20, 24, and it's in the positive x direction. So our x value for A is 24. Our y value is -4, -8. Notice that y value is pointing downward. Okay, so the x is pointing to the right, which would be positive. Y is pointing downward, which would be negative, so this is -8. Then the b value has no y value, so that's going to be 0. It's all horizontal, so it's 4, 8, 12, 16, 20. So 20. And then we get a grand total here, add up all the x values and the y values, and we get an x and a y component for the resultant. So this would be 44 in the x direction and negative 8 in the y direction. So 44 by negative 8. So imagine that each one of these is I don't know why we can't do that. Let me try that one more time here quick. Okay. There we go. Imagine this thing is 44 units long. And then the next one would be, we'll make it that. We'll make it purple. Perfect. And then we insert another straight line here that is supposedly negative 8-ish. So there we go with that. And that would be the equivalent of 44, negative 8. And then our resultant vector would be from where we start to where we end. And it would be start here, end here. And we'll make that we'll delete that. We'll make that one an arrow. So that'll be this. We start right there, and we end right there. Okay, so that will make that green color. Okay, so the resultant vector, this is right here, would be 44. This would be 8. And then the resultant vector would be Pythagorean theorem, 44 squared plus 8 squared. Square root of 44 squared plus 8 squared. And so this line would be the square root of that. And if we want to find the angle in here, then we would take the inverse tangent of opposite over adjacent. So inverse tangent of opposite over adjacent, 8 over 44. And that would give us theta. Okay? So that's how you add A and B. If we're going to add A plus D plus E, we're going to make another chart, sort of like this one here. Sort of like this one here, only this time we're going to have A, and then we're going to have D, and then we're going to have E, and we're going to have the X values. And, oh, now I know. Hang on. Let's try that again. So we'll have the X values. Nope. Let's try that one more time real quickly here. Insert straight line. There we go. So there's one. And then we'll copy and paste. And we'll drag that one right up here. And we'll make one horizontal between A and D. And then we'll copy paste that one. Let's just make another one. And then we'll make one more. And then we'll have our, try that again. Insert straight line. There we go. Kind of all over the place here. So that's how we'll end. And then we'll write in our X and Y values for each of the vectors. And we know that A has 24, negative 8. So we're going to go ahead and do that. 24, negative 8. And D has, oh wait, D starts here and it ends, that's 3 and 4 is 7, and let's just count the 4s. Maybe my graph got put off a little bit, but that's all right. Let's see, 1, 2, 3, 4, 5, and 4 is 9, and 4 is 13, and 4 is 17, and 4 is 21, 22, 23, 24. So it has 24 in the Y value. And the X value for this is -4. So -4. Notice the X from where we start to where we end. The Y value goes straight up. 24. And then the X value is pointing to the left. So that's -X. And that's +Y. Okay. So then we take the E values. Here we go. We start here at the tail on E, and it's -X and +Y. So -X is 4, 8, 12, 16, 20, 24, 28. E is -28. And E is positive. Looks like 1, 2, 3, and 4 is 7, and 1 is 8, +8. So we're going to add these all together. If you'll notice, the -8 and the +8 cancels out, so that's going to be 24 for our Y value. Then this is 24 minus 28, which is -4, and -4 is -8. It's the kind of the opposite of what we just did. We had 44 -8. Now we have -8, 24. So on the graph, if let's say we chose to make this our origin, we would be -8 this way, and then +24. So all the way up, just like so. Let me see if I can erase that. That's silly. Okay, so it would be this, and so -8. And then +24. Let's make that a little bit shorter. Oh, wait. Shorten that length a little bit. All right, let's get rid of that. Let's just start again. We'll do this, insert, and we go -8. Wait, where's my -8 and 24? So we'll do our insert, and we'll do an arrow, and let's imagine this is our origin right here. So -8 would be our X, like so. And then our Y would be +24, 2, 3, 4, 5, 6. And then our resultant vector would be, we'll make that green color again from where we, we'll make that black, stay black. And then we'll just draw this in from where we started to where we finish. Right there to the right there. And we'll make that one green. Boom, that's our resultant vector. And so our resultant vector would have a length of square root of 24 squared plus 8 squared. I'm not going to do the math on that, but that's the gist. And then the angle, of course, theta. Oh, wait, what are you doing? Let's try that again. Theta. Oh, come on. Killing me, Smalls. Okay, theta right here would be inverse tangent theta. Would be opposite. Opposite over adjacent. So opposite is the y value. So it'd be y over x. And that's equal to theta. So then you'd be able to figure that out. All right. So that is the graphical analysis of vector addition. Follow up with the mathematical analysis, and we'll do that on another video. Thanks. See ya.